how do we actually move energy from point A to B. Historically, basically, we cut the wood and then we burned it right where we had it, right? And that was the transmission. Yeah? And then, of course, the revolution came, coal came, and primarily we, of course, put the power plant next to the coal mine if we could. Yeah, oil came, gas came, pipelines, transportation. So when you think about moving one unit of energy to where it's supposed to be, that actually in the past has been not a big cost driver because it has been so ridiculously efficient. So the cost of moving a kilowatt hour or whatever, BTU, depends on where you live, from A to B, if it's oil, coal, and gas, and energy dense material, is relatively small. Now, in today's world, we're talking about electrification. So suddenly we're talking about actually transmitting energy not anymore as the pure fuel, but now as already a finished product, electricity, you want to call it. And the transportation of electricity is so much less efficient and so much more costly per unit of energy. You wouldn't think. It's probably, just to give you a sense, there's a new study that came out a few years ago, but they're talking of 20, 50 times more expensive per megawatt hour. So if you're talking whatever 1 cent cost for, let's say, for the normal historic way of actually moving gas through a pipeline or moving coal on a train to where it has to go, now you're moving it in an electricity system grid, and the cost is up to $5. It's ridiculous. It's much higher.
Right. We talk so little about cost, which is utterly shocking to me, and I found that so fascinating because I've learned about the additional costs that we incur because of the variable nature of the renewables that we're really touting now, wind and solar. And so you have to have backup systems, and that makes sense. But everywhere we've gone heavy on wind and solar, the costs have skyrocketed. And so that's an element of it that you've identified, is that transmission differential.
Well, then there's not only that transmission differential itself, but on top of that, supply and demand are much more far apart when it comes to wind and solar, right?
Yep.
Because you cannot optimize. You see, we've spent 100 years optimizing our grid infrastructure, our system, to put power plants where they're most optimized of the demand, all those things, to minimize exactly that transmission, and to optimize it. But today, nature has to basically tell us where we put it. Right. And there's various studies that say that the miles of transmission infrastructure required for wind and solar is at least twice as big compared to a conventional system. I would say it's probably 5 times more, but I cannot back that. It's just a feeling, a sense I have. Yeah. But it's absolutely incredible how we have been dismissing this issue, and that issue comes down to not only the cost, it comes down to the environmental impact.
Right. Yep.
Because think about it, right? The cost, where does the cost come? The cost comes from actually putting this stuff up.
Yeah.
And putting this stuff up doesn't only take money. Putting this stuff up also takes energy and takes raw materials.
Right.
Both of these things have an impact on the environment. Right. And that is where I'm trying to explain in the book as well, right? About that, let's go away from this, what's good and bad and green and not green. Of course we want to do the best we can going forward for our children and there's no question about it.
Yep.
But let's think what we're doing. And let's take a macro view. Hold on, guys. No one today has actually truly calculated this cost.